Performance is important. I mean, presumably this is why we're all here. We're at a NewRelic conference, a company that provides all these amazing tools for measuring performance and things because we care about performance. I care about performance because I hate going to a website. It just takes forever to load, right? Sit there and you got a white screen, you're waiting for a loading bar or something, and so do your customers. I mean, we have things like 40% of people assume a page is going to load in under 3 seconds, which means if you have a page and your competitor has a page, and somebody's clicked on both in Google search results and they wait for one to load up, they're going to use whatever one they can actually use first. We know this from tests that Akamai and Gomez testing has done. We know that a 1 second delay in page response time makes a 7% decrease in conversion rate. This is a big deal. Also, developer time is important. I am a developer, and I want to make sure that I'm not working on random things, that I want to make sure that what I'm working on actually provides value to the customer and that I can feel good about the time that I spend on doing things, especially because if I'm doing very performance work, that means I'm not necessarily making a new shiny feature. It means I'm making the existing features better, and I'm making our customers happier, and I'm making myself happier. So that brings us into performance tooling. So here I want to discuss some of the tools that I use, whether it's like NewRelic and RUM tools and things like that, to actually measure the impact that I as an engineer am having on the business. So I've been with Airbnb for the last year or so working on the performance team. It's been pretty awesome. And I like doing this because I like building software that makes people happy. And people are both the hosts and guests that use our website, and they're the engineers who have to work with our website. So it's kind of led me to the performance team where I get to build things that just make people happier. It's a real passion of mine. So to understand how to apply tooling and how to apply performance fixes, we should understand what happens during the course of a web request, which many of us might know, and I'll kind of gloss over a high-level overview of this. But it begins with a user entering a URL in a browser. This could also be a user searching for something, clicking on a link, and then getting to your page. But what happens is there's a request that's made from the user's browser to a DNS server somewhere. So we, for example, use DynDNS. You could use Route 53. There's Akamai tools. There's all kinds of different things. But this is where you're spending the first 10 to 100 milliseconds of your web request. So it's important to make sure that you're not using something that takes a ton of time. And then also somewhere kind of in between steps 2 and 3 is an SSL handshake, which could also add on a couple hundred milliseconds. So before a request has even hit your web server, you're already spending a couple hundred milliseconds doing absolutely nothing. And so we use edge servers. We use CDN servers. We use Akamai, for example. You could use all kinds of things. But what happens is the DNS points you to an Akamai edge server. And so if that request isn't cached, it's going to go all the way to the origin app server, in our case, EC2 with Amazon. At which point the app server then processes the request, starts building a page for you so it can send things back to you. So at this point, the user still hasn't seen anything. All these steps are happening. It's probably been a couple seconds before the browser begins receiving HTML and actually can start displaying things. After which we begin loading styles and images and CSS and things so that the page actually looks usable. Finish loading the assets, and then you run any post-load scripts. Maybe you have JavaScript widgets that initialize after the page is loaded. So all of these things have to happen before a user can actually do anything at all on your website. And so we're going to call this first half backend performance, which is all the time before you actually have anything on your white blank page. And we'll call this second half front-end performance, which again is all the time it takes your browser to display a ready and usable page. And we'll break this down into milestones. So we have time to first byte, which is when you start receiving data back from your server request. We have the render time, which happens as your styles and images and JavaScript is loaded. That's blocking the page load. Load time when everything's done, and then finished. And I make a distinction between load time and finished because, again, you might have content that gets AJAXed in or manipulated after the page is actually finished loaded. So this helpful diagram, half of it's knowing what to accomplish, and then the other half of the remaining bits are back-end and front-end performance. So the first part we'll talk about, because it comes first in this list of things, is the back-end performance. It's about optimizing time to first byte so that the user can begin loading your page faster. One of the tools I like, I'm going to try hard not to make this a NewRelic love story, because it very much is is NewRelic performance monitoring. NewRelic, if you haven't heard of it, is a tool that we use on our Rails and Java and Node apps that we just kind of embed, and that gives us all kinds of data and insight to what's going on in our pages during the request lifecycle. And it gives us kind of a nice view over history as we make performance changes to know, okay, after we make a deploy, have things gotten better or worse, or are things erroring and exploding and destroying performance numbers, as it does. And so we like to use this to kind of dive both into specific pages and watch what's going on, as well as look at kind of the overall performance profile of our application. So our dashboard looks something like this. NewRelic's actually changed it since I took this picture a week ago, for the better. This is an example of the dashboard graphs I monitor in particular. So I always have a browser window open with these screens on it. And so this allows you to watch kind of vertical lines for code deploys. So you can see, after one line, do things go up or down? For example, we might have a deploy where we kind of blow the caches. You can see performance go up, and then, or load times go up, and hopefully they trend back downwards if things go properly. And here you can also measure browser load times against application load times. So you can see what exactly is taking all the time in a given request. You can also dive in further. So here's a look at kind of historical data for our listings page. So if you go to Airbnb.com, you find a room and it's lovely and it takes forever to load. Maybe it's an uncached hit and our browser is taking a while. Or maybe it's super fast and it's a cached hit, or we haven't optimized things happening on. So this allows us to kind of dig into why things aren't going faster, and even when they are okay, how can we make things even faster? And another cool thing that I like to do pretty often is look at kind of the top percentile page requests and see what exactly is taking the most time. So you might have one request, for example, that takes 50% longer than most page requests, and we can see, is there, are we missing paging on comments? Is there something going on where we have a very slow SQL statement or something that's causing this to take a tremendously long time that it shouldn't be? Why are certain requests outliers to the median? And then, of course, one step further, besides actually just making our application server faster, is not hitting the application server at all, which is better, because 0 is better than any number. So one of the tools we rely on very heavily is Akamai edge caching. And so we set this up so that if our server sends back the headers that say cache this page for 20 minutes, Akamai will cache it on a server that's very close to the user. So instead of the user hitting the edge server across, so if you're making a request from Tokyo, you don't hit a server in Virginia that then has to process and then send things back, and there's packet loss and all kinds of things in the way. Instead, you load a already completed finished page that doesn't have to do any server kind of processing. So this is massively helpful, and we use it to a huge extent. So we use this for our static assets, we use this for our server-side assets. This shows we use on average 85% of the requests for assets never actually hit our servers. They actually hit Akamai and return there, which is great. So now that we've kind of looked at how to look at the backend, and there's other things you could dive into. You could go into platform-specific profiling tools and memory management things that, again, NewRelic can help you look at what the problems are. We have the front end to work on. So that's where I found the majority of performance problems happen. Because even if you have a slow server, you still have to, once all of that is finished, load images and JavaScript and CSS and the actual HTML and do parsing and rendering and reflows and all kinds of crazy stuff. So even after you get your first byte, you need to optimize the page contents. The user can actually use the page faster, because there's no point in having a page delivered super quickly that you can't do anything with. So the golden rule is make less requests for smaller content. Delete all of your images, CSS, and JavaScript, and things will load very fast. They won't necessarily look great, but they'll load super fast. So there's a lot of well-known procedures for making this happen. There's concatenating your CSS and your JavaScript. It's putting your JavaScript at the bottom of the body. It's, you can implement you can implement Speedy, for example. It'll help you make requests for things faster. Then all this happens because you have all kinds of problems in the internet: high latency, packet loss, firewalls, unreliable mobile networks. We're still talking about desktop computing for the most part, because mobile networks are a whole other game where you have all kinds of crazy packet loss, high latency, terrible connections. You also have to deal with the speed of light, which is a thing, which means you have this unavoidable latency for requests. From EC2 in Virginia, you're going to have to deal with 35, 40 milliseconds to Tokyo on the speed of light if I shot a laser which you can't do because there's steps in the way in the middle where things happen. So in this terrible diagram, it actually looks something like this. So you have a computer somewhere that talks to a modem, that talks to a router, that talks to an ISP, that goes through an undersea cable, that eventually talks to another router, modem, and cable on the other side of the world. So it isn't actually 40 milliseconds. And this happens for every, for packet trips too. So if you're using TCP and you have a lossy connection, you have to keep re-requesting data, which is terrible. And distance time the speed of light means we can change two things, which is either lower the distance or increase the speed of light, which is unlikely. So again, we use Akamai to cheat. So we move all the content closer. So again, instead of having to go from Tokyo to Virginia, we go from Tokyo to an edge server in Japan or in mainland Asia or somewhere much closer than hitting our servers. And this is super useful for all kinds of content. It's useful for pages that don't change often, like a listings page or a home page. It's very useful for images and CSS and JavaScript. And we accomplish this by having, changing the file name of the CSS or JavaScript file that we generate with Rails and sprockets and things, so that we can cache things for a very long time. And if you hit the home page and you go to the listings page, you're hitting the same JavaScript file that is loaded from Akamai or somewhere tremendously close, which is fantastic. So in order to actually measure what we change, what we need to change, our primary tool that I use is RUM. So we have both our own RUM, and we also rely on NewRelic's RUM. And this allows us to compare performance metrics against historical data, and allows us to watch the impacts of changes that we make. And the way we do it is we use Google's open source real user metric monitoring JavaScript chunk that I think everybody uses. NewRelic uses it, we use it, Akamai uses it. And what we're able to do is also throw it all into Hive, and we can put in extra parameters into it. So say we're running two versions of the same page, one where we may have made performance differences. We can actually measure directly the differences between these two things. We can check by country and see, if we have a particular slowness in Asia, maybe we should take a look at a local CDN that optimizes more for a geographical location, for example. So we watch three things in our RUM data. One of those is the median page response time. We also watch higher percentiles, like 90th, 95th percentiles. And then we watch, we keep track of how many page requests are slow or very slow. In this case, we watch for 3 seconds are slow, acceptable-ish response times. Excuse me, and 5 seconds are slow response times that we want to try to avoid as much as possible. So these are the kinds of graphs that we produce. So we run a big Hive query, I throw it into Google Docs, then we can look at, for example, page requests by a given page. So we have, hopefully everything's are trending downwards as they are. And then this allows us to catch, for example, maybe we introduced some extra images, we forgot to put them in a spreadsheet or run them through Akamai, and all of a sudden there's a big jump on one of our pages. We can quickly identify this and fix the problem and then watch it go back down so we feel happy. Similarly, you can break it down by region. So we have like Asia, Europe, US, North America, rest of the world kind of things, and see, consistently at the top, kind of the further you get away from our data centers, the slower it is. Maybe that means we need to utilize edge caching more. Maybe that means that we need to optimize better for lower bandwidth connections, things like that. And then this is an example of kind of checking different experiments. This is a really cool example. We recently enabled speedy requests for our static assets, and even more recently, we're about to flip it on for dynamic content. So you can see, as we flipped it on, kind of towards the middle of the graph, there's this really obvious gap between speedy and non-speedy requests, where we can quantify the work that we've put in and say, does it actually make sense to keep this running and to maintain this? Then it looks like it does, because it's faster. So NewRelic's Subtext, of course, is very similar to what we watch for slow and medium-sized requests. And it's an idea of figuring out how many people are satisfied with the page loads. If it's tremendously slow, then we have things to fix because people are unhappy. So then there's kind of the deeper dive into specific pages. So all these things kind of help us dive into pages or overall performance differences. To actually fix these things, there's a series of tools. And the easiest thing, of course, that I use the most often when actually fixing a page's slowness is the browser's network tab. Because it's really useful to see the waterfall, what requests for what assets are blocking things off from other assets. So in this case, nothing gets loaded until a page is loaded. And so this is indicative of, well, maybe we need to find a way to introduce HTTP streaming or chunking so that we can begin loading some of the assets ahead of time, and so we can identify these kinds of problems. Additionally, you can install PageSpeed, which I love, a browser extension by Google that I'm sure a lot of us are familiar with. You hit a button that says Analyze, and it'll say, here's all of your problems. These aren't gzipped. This JavaScript should be minified. These images could be sprited or could be recompressed with better JPEG compression. A huge bevy of tools. So basically, if you run PageSpeed, just run down the checklist, you've already gone a really far way on your front-end performance profile. Web page test is also super cool. And this is useful to, again, watch waterfalls and to test from different areas in the world. So there's some providers that will do this for you. Web page test is a free tool that I like a lot. So we can do things like if we're trying an alternate CDN in Europe, for example, I can run a test out of Europe against our stuff and see what a real request looks like from Europe and see, are they getting the right CDN? Is it actually faster? And I can check performance data. So the waterfall that web page test gives you, you can compare before and after with any number of requests and see if the waterfall shrinks and reorganizes and is displayed the right way, or if you really hadn't made any kind of differences. It also provides you with a video that's super cool, and hopefully we'll get to play in a second. And one of the things that we did here is we optimized our search page. And if I can get to play, is playing? Oh, sorry, my notes is not playing. Yeah, so you can see the difference where the render time is complete because we start doing things like lazy loading images. And in the first one, we waited for everything to load before you could actually interact with the page. So it gives you this really awesome view into when things are usable for your users from anywhere in the world, which is really nice. Let's kind of bring it all together. Performance makes people happier. Working on the right thing makes people happier because then you can both spend your time working on the right things. Your engineers feel like they're building the right things. Using data to make sure that you're working on the right things is always a good thing. It's just like A/B testing. You would never run an experiment without testing. You wouldn't make any performance changes without testing. And having the data to back up what you're working on. We identify slow requests with NewRelic and run data. We identify what is slow on a given page using browser testing and web page tests and page speed and things like that. And then we track all the changes we make, again, with NewRelic and RUM. So there's kind of this full cycle. Watch what you're changing, make sure it actually makes sense, and then keep rolling out those changes across your entire website. That basically wraps it up. Have any questions? Yeah. They are very dramatic. Can you talk about what optimization? Can you talk about the optimizations that you did there? Sure. So she asked. So she said the video is fairly dramatic. Can I talk about some of the optimizations we did to get that working? So we did a few things. So kind of the before and after search. One of the primary things, problems that we had on the search page, is we're using kind of a weird image size between mediums and larges. So we kind of have breakpoints for the images that we generate. So if you upload a photo of a listing, there's like a 300 pixel wide, and then it jumps up to 900 pixel wide, for example. And so we were loading like 400 pixels. And so we couldn't really upscale the lower resolution version, so we were using the large version. So we were downscaling, which means you were loading, I think we were loading 70% larger than we needed to. So this is with an experiment where we tried kind of changing the design a bit so that we were only upscaling a tiny little bit. And since then, we're working on dynamic image resizing, which helps a lot of things. Another part of it was kind of lazy loading some of the extra JavaScript we're using. But most of it was when we're loading 24, I'm making up numbers, but a lot of images. But you really only need the first couple images for the page to look complete. So we started lazy loading all the images after that, which means you could start interacting with the page and scrolling and clicking on things that you could see while everything kind of loaded up in the background. And so that made a several second difference, especially for this use case, where you're otherwise loading lots of images. It's pretty cool. Yes? So we asked at Airbnb, do we have any specific team whose job is to work on, look at NewRelic or work in performance data and things like that? There has been for a while now. And so I've been on the performance team with a couple other guys, kind of a rotating team of people, since January. Since then, I've kind of been working on writing wiki pages and talking with the team and things. So I've kind of transitioned from kind of just me and a couple other people working directly on performance issues to kind of consulting with other teams and helping them learn how to set up caching and how to set up what are good performance guidelines to use? How do I lazy load JavaScript and when should I versus loading it right on the page and things like that. So the goal is kind of shifting it off the responsibility so that it's not just us necessarily. And we're kind of getting to the point where it's a shared responsibility between all the teams. Yes? How do you manage the TTLs for content cached at the edge? So what we do, it's very much on a page-by-page basis. So we know the homepage, for example, we have two fairly global times. One is 5 minutes, one is 20 minutes. We found that a lot of times anything more than 20 minutes doesn't buy us a whole lot because it's either not a popular enough page that people hit it that caching really matters, or anything longer than that makes it difficult to make changes. And so what we do is we set it about 20 minutes. If we need to, we can also make a call out to our CDN to purge the cache if we make a deploy. But it's on a case-by-case basis. I think most pages are probably 20 minutes with a couple that are closer to 5. It just seemed like a fairly good number based on the amount that we have to blow our caches. Yes? Sorry, is there a time? What? It's a measure that you can measure. I didn't quite hear, sorry. Time to interact. Yes, sorry. Yeah, so generally what I look at is the page load time, because that's generally the time where the browser is not spending a lot of its like CPU and memory cycles trying to render a page. And usually that's when it's easiest to interact with because like lagging isn't scrolly and you can actually interact with things. So I generally look at the total page load time or the render time, which is pretty indicative of that time. Yes? Strategy for dealing with dynamic content with the CDN. So depending on the page and whether or not we want to cache it, we do a few things. We have some rules saying that if we have, for example, a page that's personalized if you're logged in, we'll have the CDN watch for a logged in cookie and not served cache content. And then in those cases, what we have is in our application, which is mostly Rails, we use fragment caching. So we might cache, for example, on a listings page, related listings that don't change, but the body of the page might, for example, if it's personalized, then be generated on the server side. So this way, we can kind of selectively choose what pages based on the existence of a login cookie, kind of, for whether or not we should cache a dynamic page or not. And if it's something that we never want to cache, we just never send the cache header. Yes? Their cache, so we asked if you know a whole lot about the difference between Akamai's edge caching and CloudFront. So we tried out CloudFront a little bit for our static assets. We found it was easier just to kind of stick with Akamai since they're very useful for our dynamic front-end caching. And they also provide a lot of other tools. Like we're looking at them, like they have a new security suite, which is pretty cool. So it's kind of nice having everything in one place. And then if there's a really big draw to using another, like if there's a big performance difference between switching CDNs, we would do that. One of the recent examples is we just switched DNS providers, for example, from Route 53 to DynDNS. And that's a little bit of it is there's a bit of a performance improvement with DynDNS, although DNS lookups get cached anyway, so it's not a huge deal. But they also provide more features that were interesting to us, like per country DNS splits. So we could split up the CDN per country instead of per region, which is really cool. So something similar would apply to Akamai. So we would experiment with it. I haven't recently, probably in the last year or so, but I imagine if it was better, we would look at switching. If it's better. Yes? Yeah, so we asked, have we looked at displaying images responsively based on whether it's a retina that needs like a kind of 2 times image DPI, whether they're on Wi-Fi or mobile information. We haven't started doing that. We do get that information from our CDN from Akamai. We'll pass this on information about the network they're on, so we know if they're on a 3G network or Wi-Fi. I'm not sure that we serve a ton of 2x DPI images right now, but imagine once we do that, that would be something that we would definitely do. We're good. Yeah, one more? Sure. What are some mistakes we made? Great question. Got a good story about that one. So on our search page, one of the things that I thought we would do is Google Maps is a lot of JavaScript and a lot of images. And so we thought what I would do is I would try lazy loading the Google Maps JavaScript on search. And what ended up happening was the search page would render half complete, and they would render all of the optional content. And then eventually later on, Google Maps would come in. And so it actually, like if you look at the web page test videos, it would show that it was complete sooner, so the metrics were better. But the actual time till the page looked complete, and you could actually use maps and get an idea of like where you're looking at for these listings, came in much later, a couple seconds later. So it actually made the experience much worse, even though the metrics were better, to do lazy loading in that case. And so that's a common pitfall, is measuring just the metrics and not also the visual output of performance changes. Yes? So we asked how we tie performance metrics to business metrics like conversion and things like that. So some of the things we can do, so we haven't, we've only done it to a very small extent. I'd like to try it a little more later, but one of the things that other companies have done that I'd like to try out, if we can stomach it, is doing things like artificially inflating load times and comparing the differences. And so that's one of the awesome things about the RUM solution, is we can have 2 experiments, one where we artificially inflate load time by 100 milliseconds, 200, or half a second, or even more, and then use RUM to watch similarly, how do our metrics drop for each layer of the experiment. There's companies that have done that. That's a lot of where the metrics that Akamai and Gomez have, where they say like 7% of visitors will leave for every extra second that your page load happens. It's from experiments like that, which are fairly well tested, so we haven't had a need to specifically for us, because it's probably about right, but it would be neat. Yes? Do we use RUM in place of Optimizely for A/B tests? We use RUM separately than Optimizely, I think. If I remember correctly, Optimizely allows you to kind of change content on the page after load. Is that correct? So what we do is we have an A/B testing system on the Rails side called Trebuchet that allows us to launch, whether either run different backend code, change you to a different URL path, maybe change the content on the page. And so that we all do server side instead of client side. So we haven't tried implementing Optimizely, and I would be curious to see how that would impact performance as well. If you're modifying content after the page is loaded, that might increase page load time. But I personally haven't used Optimizely, so I'm not sure. But I definitely see them as kind of separate things. That's pretty good. One more, yes. Plenty more. Do you measure JavaScript performance after the page load? I do kind of less through automated metrics and more kind of on a page-by-page basis. Similarly, because it's kind of, the way I see it is it would be nice to do the minimal to get the page loaded and functional, and then lazy load a whole lot of JavaScript afterwards to upgrade the experience, right? So there is some amount of profiling that I do. Like I'll use the built-in like Chrome developer tools has like a JavaScript memory and heap profiler and things like that. So I do that on a case-by-case basis. Usually what happens is unless there's a really bad situation, it's usually less heavy than finding ways to like send down less images in CSS. So the biggest bang for a buck is definitely reducing the size and amount of requests. And then once we've got that under control, it's useful to then go and profile JavaScript on a page-by-page kind of basis. I think we're good. Yeah.